Welcome to this explainer. Industrial chiller maintenance is kind of stuck in the dark ages right now. It's tedious, it's highly manual, and honestly, it's just a massive headache. But today, we're looking at how PitBot is completely redefining industrial efficiency by shifting this old-school chore into a high-speed robotic science. Let's dive in.
To really grasp the urgency here, just look at this number. 117,000 Hong Kong dollars. That is the staggering monthly cost in wasted electricity for a standard facility when it suffers from just a single degree, literally 1 degree Celsius, of thermal exchange inefficiency. This massive energy bleed is exactly why we desperately need a smarter solution.
And this comparison right here perfectly illustrates what we're up against. We are looking at a fundamental shift in the whole user journey. In the old world, you've got technicians physically squeezing into these dark, confined blue drums, painfully feeding cleaning hoses into tubes one by one. But in the new world, you have this rigid, highly precise KUKA robotic arm stepping in to do all the heavy lifting.
Honestly, calling the old manual approach a bottleneck is a huge understatement. It's a full-blown industrial crisis. We're talking about requiring 6 to 8 weeks of massive facility downtime, all happening right in the middle of a severe labor shortage. In fact, it's gotten so bad that there are barely any qualified technicians left to actually do this work.
But wait, it gets worse. It's not just slow, it's incredibly subjective. Client technicians naturally suffer from attention fatigue when they're manually monitoring these tubes. It's only human, right? But that means minor anomalies get overlooked, and missing even a little bit of tube fouling triggers those massive energy spikes we talked about earlier.
So that brings us to the innovation pivot, entering the PitBot solution.
PitBot is really all about augmented human capability. By taking this grueling physical labor and mechanizing it with a heavily anchored robotic system, we're breaking right through that physical ceiling. This system literally slashes that nightmare 8-week maintenance bottleneck down to just 3 weeks. That is a massive operational win.
Now, here's where the real magic happens: parallelism. Instead of a technician struggling with a single hose, PitBot uses a motor-driven, multi-flexible manifold that blasts 200-bar precision water jets into 3 tubes simultaneously. So rather than going one by one, the robot is doing 3 at once. That is an instant, guaranteed 3 times efficiency gain right out of the gate.
And to achieve this level of precision, the system runs on something called physical AI. This isn't just software living in a server somewhere. Physical AI actually senses, reasons, and acts flawlessly in the unpredictable physical world, integrating smart algorithms directly with rugged hardware.
Think of visual large language models as the robot's intelligent eyes. They can instantly spot deformed or blocked tubes on the fly. But, and this is absolutely crucial, it's all backed up by a remote human-in-the-loop tablet interface. This ensures ultimate oversight and guarantees total safety for the technicians running the show. Take a look at this comparison table. It really highlights why PitBot's strategy is so smart. The old vision of full autonomy meant heavy vehicles, massive software liability, and sky-high costs. PitBot uses a lightweight suitcase model. By sticking to a manual mobile base, combined with a smart robotic arm, it entirely eliminates the need for expensive navigation systems, keeping it portable and drastically reducing capital cost.
And we're not just stopping at cleaning. The robotics can actually be equipped for other tasks down the line to unlock future asset optimization. The KUKA arm can measure physical resistance in real time as it works, creating a highly detailed scale map of the chiller. This completely shifts maintenance from reactive, putting out fires cleaning, to continuous, predictive scheduling.
Now, you might be wondering, is this actually working out in the real world? Absolutely. This isn't just some theory. It's backed by severe, validated pain points from industry giants like Veolia, and it's been accelerated through critical developmental support from both the AVNet and HKSTP co-incubation programs.
So, with robotic parallelism completely redefining the absolute physical limits of what's possible, I want to leave you with this final thought. How much operational revenue are you literally leaving on the table by clinging to the slow, manual bleed of the status quo? Thanks for joining me for this explainer, and definitely think about how this kind of tech could change the game for your operations.